Okay, the first problem here is to take the derivative with respect to x, and that is dy dx equal y prime. Using the power rule, it's going to be 10x plus 11 minus 12x to the minus 4, and that is simply answer D. Second problem is to find the second derivative. So you've got to do the first derivative first and then do the second derivative. Y prime would equal, using the power rule, 8x plus 12 minus 15x to the minus 4. Just leave it in this form and do the second derivative. Second derivative would be 8. The derivative of 12 is just 0. And then the last portion would be plus 60x to the minus 5. And that is answer C. Third problem is to find the first derivative, and looks like the easiest thing to do is to use the product rule. Notice you could multiply everything out, which would take a little bit of time. You're still going to have to multiply some things out, but let's use the product rule. Y prime would be the first term, which is 5x minus 3, times the derivative of the second term, which is 15x squared, minus 2x, the derivative of 1 is 0, of course. And then finally, the second function, 5x cubed minus x squared plus 1, times the derivative of the first function, which is just simply 5. After you multiply this out by foiling it, you get 75x cubed minus 45x squared minus 10x squared. Plus 6x plus 25x cubed minus 5x squared plus 5. And after you collect all the terms, you'll get 100x cubed minus 60x squared and 6x and a plus 5, and that's the answer, which is looks like answer B. Fourth problem, you need to take the derivative, and there are a couple of ways you could do this, but I think either one of them is just about as easier as the other one. What I would think you would do here is just write out the product here. And when you write out the product, notice turns out to be really easy. You get x squared. When you do the outside, you get -1. When you do the inside, you get +1. And then the last is -1 over x squared. And that equals just simply x squared minus x to the -2. Notice that now, taking the first derivative is very simple. It's just simply 2x plus 2x to the -3 equals 2x plus 2 over x cubed, which happens to be answer A. Fifth problem is one in which you're going to have to use the product rule. G prime of x would be equal to the denominator, which is x squared plus 6x, times the derivative of the top, which is, or the numerator, which is 2x, minus the numerator, x squared plus 5, times the derivative of the denominator, which is 2x plus 6, divided by the denominator squared, which is x squared plus 6x, quantity squared. Once you multiply this out, you get 2x cubed plus 12x squared minus 2x cubed minus 6x squared minus 10x minus 30, all over x squared plus 6x, quantity squared. And after simplification, you're going to get 6x squared minus 10x minus 30. Notice that the denominator can be written as x squared times x plus 6 squared. And that turns out to be answer D. Number 6 is take another derivative, and we need to use a product rule. So the derivative y prime would equal the first times the derivative of the second, which is e to the minus x times -1. Notice we had to use a chain rule. This was like e to the u, where u equal -1, plus the second function, which is e to the minus x, times the derivative of the first, which is 8x to the 7th. Simplifying this, you get 8x to the 7th times e to the minus x minus x to the 8th e to the minus x, which is answer B. Problem 7 is another function in which you need to take the derivative of a product. Notice you got lots of practice here. Y prime would be equal the first function, which is 3x squared, times the derivative of the second function, which is minus e to the minus x, plus the second function, which is e to the minus x, times the derivative of the first, which is 6x. Combining this, you get 6x e to the minus x minus 3x squared e to the minus x, which you can factor into 3x e to the minus x onto 2 minus x, and that happens to be answer B. The 8th problem is best worked by rewriting the function. This would be the 7th root of x to the 6th, which would be written as x to the 6/7, plus x to the 6e power. Using the power rule now, you get y prime is equal to 6/7 x to the 6/7 minus 7/7 plus 6e x to the 6e minus 1. So y prime is equal to 6/7 x to the minus 1/7 plus 6e x to the 6e minus 1, which is answer C. Ninth problem. Seems to me that it would be first easier to multiply out everything rather than use the product rule. P would equal q to the 15th, which is first, plus 6 q to the 8th, plus 4 q to the 7th, plus 24, all divided by 2q squared. Rewriting that, you get 1/2 q to the 13th plus 3 q to the 6th plus 2 q to the 5th plus 12 q to the minus 2. Now that you have it in this form, you can take the second derivative of p, which is equal to 2p, equal to dp dq is equal to 13/2 q to the 12th plus 18 q to the 5th plus 10 q to the 4th minus 24 q to the minus 3. And that is answer C. Notice you can write the last term as minus 24 over q to the 3rd power. The next problem, we're asked to find the derivative of a quotient. And we're not given the specific function, except we're given the value of the functions at the point 1 and the derivatives at the point 1. So basically, you would calculate d dx of u over v is equal to v times u prime minus u times v prime divided by v squared. And that is the quotient rule. Now, this is equal to, we want to calculate this at x equal 1. So this would be v at 1 times u prime at 1 for completeness. I'll write this, v at 1 times u prime at 1 minus u at 1 times v prime at 1 divided by v at 1 squared. Well, you're given that v at 1 is 6, u prime at 1 is minus 7, minus u at 1 is 5, and v prime at 1 is minus 2, and then v at 1 is 6, so v at 1 squared would be 36. So we get minus 42 plus 10 over 36, which is equal to minus 32 over 36, which is minus 8/9. And that is answer A. Here we want to find the equation of the tangent line to the curve y equal 8x over x squared plus 1 at the point 1 and 4. So we need to find the derivative of this function at x equal 1. Y prime then would be equal to, using the quotient rule, x squared plus 1 times the derivative of the numerator, which is 8, minus the numerator, which is 8x, times the derivative of the denominator, which is 2x, divided by x squared plus 1 quantity squared. Multiplying this out, we get 8x squared plus 8 minus 16x squared divided by x squared plus 1 quantity squared. So y prime is equal to 8 minus 8x squared over x squared plus 1 squared. So y prime at x equal 1 is equal to 8 minus 8 over 2 squared. Just makes it easy. The derivative is 0. So m is 0. This makes it very simple to write the tangent line as a horizontal one. And we get y minus y1 is equal to m times x minus x1. X1 is equal to 1, but m is 0, so this doesn't matter. So we get, and y1 is 4. So we get y minus 4 equals 0, and y is equal to 4. The minute you knew the tangent line was horizontal, you knew, and it went through the point y equal 4 and x equal 1, you know it has to be y equal 4. Problem 12, we have the position of a body moving on a coordinate line. S is in meters and T is in seconds. We want to find the body's speed and acceleration at the end of the time interval. Well, the velocity as a function of time is equal to s prime, first derivative, and that would be 6t plus 3. And at the end of the time interval, the velocity at t equal 2 is 12 plus 3 equal 15. Now, the speed is equal to absolute value of velocity. It turns out that this particular example, the speed is 15 at the end of the time interval. Notice if that had been, the velocity had been minus 15, the speed would have still been plus 15. Now, the acceleration as a function of time is equal to the first derivative of the velocity, which is 6. So the acceleration is equal to 6. So looking for a 15 and a 6 answer, we get answer D. Our 13th problem, we're given a position of a body moving along the s-axis is s equal t cubed minus 27t squared plus 240t. Find the body's acceleration each time the velocity is equal to 0. Well, to get the velocity as a function of time, it's equal to s prime, and so we need to take the first derivative of the position, which is equal to 3t squared minus 54t plus 240 equals 0. Now we want to find the body's acceleration each time the velocity is 0, so we need to find the times that make the velocity 0, factoring a 3 out of this expression. We get 3 times t squared minus 18t plus 80 equal to 0, and we get 3 times t minus 10 t minus 8 equals 0. So the velocity equals 0 at t equal 10 and t equal 8. So let's go find the acceleration at these two times. Well, the acceleration is equal to the derivative of the velocity, which is the second derivative of the position. So we need to calculate the second derivative, which is 6t. By the way, guys, I left a t out right here. So the derivative of the velocity would be 6t minus 54. So A at 8 would be 48 minus 54 equals minus 6, and a at 10 would be equal to 60 minus 54, which is equal to plus 6. So a at 8 equal minus 6, a at 10 equal plus 6. So that would be answer A. Fourteenth problem, we given that at time t more than equal to 0, the velocity of a body moving along the s-axis is given by v equal t squared minus 8t plus 7. And the question is, when is the body moving backwards? It's going backwards when velocity is negative. So, in order to see where t squared minus 8t plus 7 is less than 0, we need to solve t squared minus 8t plus 7 equals 0 and find the points where the velocity is 0, and that's t minus 7 times t minus 1 equals 0, so that's at t equals 7 and t equal 1. If you graph this equation, you see that it's a parabola looking like this, and this is t, this is the velocity, and it's 0 between t equals 7 and more than 1, and that's answer B. Problem 15, we have a ball dropped from the top of a building. It has a height as a function of time of 256 minus 16t squared after t seconds. How long does it take the ball to reach the ground? And what is the ball's velocity at the moment of impact? Well, it'll hit the ground when the distance is 0. So that's 256 minus 16t squared equals 0, or 16t squared equal 256. T squared is equal to 16, and t equals plus 4. Now the velocity is equal to the derivative of the position, which is equal to minus 32t. So at t equal to 4, the velocity at t equal 4 is equal to minus 128. So that's answer A. Problems 16, you're given 3 graphs. One is going to be the position, the other is going to be the velocity, and the third would be the acceleration. So you need to look at these curves and see if you take the derivative of, say, the velocity, the one you think is a velocity, does one of the other curves look like it would be the velocity? Now, taking a look at that, you've got this red curve. It looks like here the derivative is 0, and there's another curve right below it that's going through 0 at that point. It seems to also have a tangent line that's horizontal right here, and the other curve, the blue one, is going through 0. Notice everything else fits also. If you look at the red curve here, you have a negative slope tangent line, and the other curve is below the line there. Over on this side, you have a positive tangent line. And notice the other curve is more than 0, so that corresponds. And then if you now assume that this is position, and that the blue is velocity, looking at the derivative of this function, it looks like the straight line is going through 0 at that point, so that would correspond to a derivative of 0, which would mean the acceleration would be 0 at that point. And it looks like everything fits. So A would be the acceleration. The position would be the C curve, and so looks like C is position, A is acceleration, and B is velocity. Everything seems to fit. Number 17, you got a driver, the car is traveling at 42 feet per second. He suddenly applies the brakes. The position of the car is given by S equals 42t minus 3t squared. T seconds after the driver applies the brakes. How many seconds after the driver applies the brakes does the car come to a stop? Well, it comes to a stop when the velocity is equal to 0. That means that S prime, which is equal to velocity, equals 42 minus 6t equals 0. That means that t equals to 7. So 7 seconds after he applies a brake, he comes to a stop. Problem 18, you have a position of a body moving along the coordinate line, and you want to find the body's velocity at time t equal pi over 4 seconds. S prime, which would be equal to the velocity, is equal to 10 cosine of t minus or plus sine of t. Notice the derivative of cosine of t is minus sine. So we get 10 cosine of t plus sine of t. Therefore, the velocity at pi over 4 is equal to 10 cosine of pi over 4 plus sine of pi over 4, which is equal to 10 times the square root of 2 over 2 plus the sine of pi over 4 is also the square root of 2 over 2. So we get 11 square roots of 2 over 2, which is answer A. Problem 19 is to find the derivative. dr d theta is going to equal 0. The minus, using the product rule, theta to the 7th times the derivative of the second term, which is minus sine of theta, minus cosine of theta times d theta to the 7th with respect to theta, which is 7 theta to the 6th. So this is equal to theta to the 7th sine of theta minus 7 theta to the 6th cosine of theta. And that looks like answer D. Problem 20, we need to find the derivative. S prime would be equal to 2t. Derivative of cosine is minus sine, so this would be plus sine of t. And the derivative of e to the t is just e to the t, so that would be 4 e to the t, which would be answer C. Problem 21, we want to take dq dt. Here we're getting into the chain rule. dq dt is going to be minus sine of the square root of 6t plus 11 times d dt of 6t plus 11 to the 1/2. And so we get minus sine of the square root of 6t plus 11. The derivative of this is just 1/2 6t plus 11 to the minus 1/2. Don't forget the derivative of the u, the inner function here, which would be 6. So we had to use the chain rule twice. First time we used the chain rule was here, and the second time we used a chain rule, it was here. So combining all this, we get minus sine of the square root of 6t plus 1 times 3 over the square root of 6t plus 11, and that is answer B. Put the 3 right here. Problem 22 is another chain rule problem. dq dr. First of all, write q is equal to 16r minus r to the 5th to the 1/2 power. So you get dq dr is equal to 1/2 16r minus r to the 5th to the minus 1/2 power. Now you got to realize you have to take the derivative of the inner function u with respect to r, and that's 16 minus 5r to the 4th. Simplifying this, you get 16 minus 5r to the 4th divided by 2, bringing this to the minus 1/2 down to the denominator. We get 16r minus r to the 5th, square root off, and it looks like that is answer D. Now this problem is going to require the chain rule more than once. First, using the power rule, we're going to get h prime of x is equal to 5 cosine of x over 1 plus sine of x to the 4th power times, using the chain rule, d dx of cosine of x over 1 plus sine x. Here you're going to use the product rule, and you get 5 cosine of x over 1 plus sine of x to the 4th power times 1 plus sine of x times the derivative of cosine of x, which is minus sine of x, minus cosine of x times the derivative of 1 plus sine of x, which is just going to be cosine of x, divided by 1 plus sine of x, quantity squared. That's a quotient rule. Now, we're going to get 5 cosine of x over 1 plus sine of x to the 4th power, multiplying all of this out, we're going to get minus sine of x minus sine square of x minus cosine squared of x all over 1 plus sine of x quantity squared. And notice that this is equal to, first of all, cosine square x plus sine square x equal to 1. So this portion is equal to minus 1. So factoring a minus 1 out, we get minus 5 cosine of x over 1 plus sine of x to the 4th power. And the denominator up here is going to be 1 plus sine of x, because we had factored minus 1 out. The denominator still has 1 plus sine of x, quantity squared. So this will factor out, and we'll get 1 plus sine of x to the 1st power here. And combining all this, we get minus 5 cosine of x to the 4th and 1 plus sine of x to the 5th power after everything is simplified. And that is answer B. Number 24, we want to find the derivative. Here again we have to use a chain rule. First derivative of f is going to be minus sine of 8x plus 6 to the minus 1/2 power times d dx of 8x plus 6 to the minus 1/2 power. That's the chain rule. Notice that this is your inner function u. This is going to equal minus sine of 8x plus 6 to the minus 1/2 times, taking the derivative here, you're going to get minus 1/2 8x plus 6 to the minus 3/2. That's minus 1/2 minus 1, which is minus 3/2, times the derivative of this other inner function here, which is 8. So after taking into account all the signs and multiplying out by the 1/2, we're going to get 4 sine of 8x plus 6 to the minus 1/2 over 8x plus 6 to the 3/2. And that is answer B. Well, here is just a classic case of the chain rule. It's a composite function. F of g of x is just simply equal to x to the 5th plus 2 quantity squared. So the derivative of f of g of x is going to be 2 times x to the 5th plus 2 to the 1st power times 5x to the fourth, chain rule, and so we get 10 x to the fourth, 10 x to the fourth times x to the fifth plus 2. They wanted us to evaluate this at x equals 0. Very quickly you see that this whole thing is equal to 0 anyway. Problem 26, we want to use implicit differentiation to find dy dx. So we take d dx of cosine of xy plus d dx of x to the fourth equal d dx of y to the fourth. So d dx of cosine of xy is going to be minus sine of xy times d dx of xy plus 4x cubed equals 4y cubed dy dx. Notice we use a chain rule here, taking the derivative of y to the fourth with respect to x. It's 4y cubed dy dx. Now we need to continue this, and we get minus sine of xy. d dx of xy is going to be x dy dx using the product rule plus y times d dx of x, which is just simply 1. And then we get plus 4x cubed equal 4y cubed dy dx. Now, we need to collect all of the terms with a dy dx in them. And I think I prefer to carry things over on this side, and dy dx, bring that out, and I'll get 4y cubed plus x sine of xy equals 4x cubed minus y sine of xy. And then finally, solving for dy dx, I'm going to get 4x cubed minus y sine of xy divided by 4y cubed plus x sine of xy. And that looks like it's answer A. Number 27 is also requiring implicit differentiation. You want to find dy dx. So we take d dx of xy plus d dx of x plus d dx of y, which is just dy dx, is equal to d dx of x squared y squared. Doing this, we use the product rule, and we get x dy dx plus y times derivative of x with respect to x, which is just plain 1. d dx of x is 1 plus dy dx is equal to, we have a product here, x squared times 2y dy dx. That's the product rule and the chain rule, plus finishing the product rule is the second, which is y squared times d dx of x squared, which is going to be 2x. And now we want to try to combine all the dy dx portions. And so I get dy dx with an x, and then I'm going to have a plus 1. I'll factor that out, and then taking care of this, I get minus 2 x squared y. And what I've got left is 2 xy squared, and this goes over here to give me a minus 1, and this gives me a minus y, and calculating dy dx, I'm going to rewrite this a little bit into 2xy squared minus y minus 1, just reordering it a little bit, divided by x plus 1 minus 2x squared y. And looking at possible answers, it looks like it is answer C. We want to find a formula for the derivative of the inverse of f. Now, first of all, there are all kinds of ways to do this. In this particular case, I would write y equal f of x equal x to the 7/3 power. So let's find the inverse function. Remember, the way to do that is to interchange x and y. So let's say that x is equal to y to the 7/3, and then solve for y. X to the 3/7 power equal y to the 7/3 to the 3/7 power equal y. So the inverse function of x is equal to x to the 3/7. So now let's take the derivative of the inverse function. It's equal to d dx of x to the 3/7. It's equal to 3/7 x to the 3/7 minus 7/7 equals 3/7 x to the minus 4/7, which is answer B. Okay, number 29, we want to take the derivative of a natural logarithm function. Remember that if you have d dx of ln of u is equal to 1 over u du dx, chain rule. So dy dx is equal to 1 over 8x squared. d dx of 8x squared is equal to 1 over 8x squared times 16x, and that is equal to 2 over x, which is answer B. Now, next one is to find the derivative with respect to an exponential function. And here the idea is if you have d dx of e to the u, the answer is e to the u du dx, chain rule again. So y prime is equal to e to the 4 times the square root of x plus x to the 5th times d dx of 4x to the 1/2 plus x to the 5th, and this is equal to e to the 4 square root of x plus x to the 5th times 1/2 times 4 x to the minus 1/2 plus 5x to the 4th Simplifying this, we get 2 over the square root of x, which is this term, plus 5x to the 4th, all times e to the 4 square root of x plus x to the 5th, and that is answer A. Number 31, here we got the derivative of ln of x over x to the 5th. You need to do the quotient rule. Y prime would be x to the 5th times the derivative with respect to x of ln of x minus ln of x d dx of x to the 5th divided by x to the 10th power. This is equal to x to the 5th times 1 over x minus 5x to the 4th ln of x, all divided by x to the 10th, which is equal to x to the 4th minus 5x to the 4th ln of x divided by x to the 10th. And simplifying this, that's 1 minus 5 ln of x over x to the 10th, and that's answer D. This is a case where we want to take the derivative of an inverse cosine function. You might remember that d dx of inverse cosine of u is equal to minus 1 over the square root of 1 minus u squared times du dx, chain rule. So this would be equal to y prime equals minus 1 over the square root of 1 minus u squared. Now u, notice, is 9x squared minus 4 quantity squared times du dx, which is 18x. So we get minus 18x over the square root of 1 minus 9x squared minus 4 quantity squared. And it looks like that answer is C. Problem 33, we're taking the derivative of an inverse sine function. You may recall that d dx of inverse sine of u is equal to 1 over the square root of 1 minus u squared times du dx. So we get dy dx equal 1 over the square root of 1 minus u squared. Now, u is equal to 1 over x squared. So we're going to square that times d dx of x to the minus 2. This becomes 1 over the square root of 1 minus 1 over x to the 4th. The derivative of x to the minus 2 is minus 2x to the minus 3. This becomes minus 2x to the minus 3 over the square root of x to the 4th minus 1 over x to the 4th. And this is going to become minus 2. I'm going to take the x to the minus 3 and put this down on in the denominator times the square root of x to the 4th minus 1 divided by x to the 4th. This is minus 2 over x cubed square root of x to the 4th minus 1 divided by x squared. And this becomes minus 2 over x times the square root of x to the 4th minus 1. And that looks like answer A. This problem, we have the kinetic energy of an object with mass m and velocity v is k equal 1/2 mv squared. How is dm dt related to dv dt if k is a constant? Okay, now we're assuming that m is not necessarily constant and it's a function of t, and that v is not a constant and is a function of t. However, k is constant. So let's write down what we know: k equal 1/2 mv squared. In order to get a relationship between dm dt and dv dt, we need to take ddt of both sides. ddt of k is equal to 1/2 ddt of mv squared. Notice we're going to have a product rule here. ddt of k is equal to 0. It's equal to 1/2. Now we're going to have to use the product rule. It's going to be m times dv squared with respect to dt plus v squared over 2, notice I still have my 1/2 here, times dm dt. That was a product rule. Now we've got to go and use the chain rule, 1/2 m ddt of v squared is going to be 2v dv dt plus v squared over 2 dm dt, and you're going to see that we're going to be able to cancel out the 1/2s here and get that dm dt is equal to minus 2mv dv dt, all divided by v squared. All you need to do is solve for dm dt, and it looks like that answer is number A. By the way, just to look at it, you need to cancel the v here, and you get minus 2m over v dv dt. That's how you can make it the same as answer A. Number 35, you got the range of a rocket or a range of a projectile is related to the initial velocity v, and projection angle theta by the equation r is equal to v squared sine of 2 theta divided by g, where g is a constant. How is dr dt related to d theta dt if v is a constant? Well, r is equal to v squared sine of 2 theta over g. Dr dt is equal to v squared over g. Remember, v and g are constants, times cosine of 2 theta times 2 d theta dt. Remember, we have to take d dt of 2 theta, which is equal to 2 d theta dt. So dr dt is equal to 2v squared over g cosine of 2 theta d theta dt, and that is answer B. Okay, this problem, we got a wheel with a radius of 3. Draw yourself a picture. The wheel has got a radius of 3. And it rolls at 18 radians per second. So if we draw ourselves a little coordinate system here and let this be theta. We know that d theta dt is equal to 18 radians per second. And we're asked to find how fast a point on the rim of the wheel is rising when this angle is equal to pi over 3. So how fast is it rising? Well, we can call this y, and this is just an old unit circle problem, except it's not a unit circle, it's a radius of 3. We can write down that y is equal to 3 sine of theta. Notice you got, this is y, this is 3, this is theta. So y is equal to 3 sine theta, so dy dt, the amount that that point on the rim is rising would be 3 cosine of theta, d theta dt. So this is 3 cosine of theta, and the question was if the angle is pi over 3, so we place pi over 3 in there, and d theta dt happens to be 18. Cosine of pi over 3 is 1/2, so we get 3 times 1/2 times 18, and that is 27 meters per second. Number 37, we got a piece of land that's shaped like a right triangle. Two people start at the right angle of the triangle, which is right here. Start walking at the same time, walk at the same speed along different legs of the triangle. This is x. And since they're walking at the same speed, we can let this be x also. And if the area formed by the positions of the two people and their starting point is changing at 2 meters squared per second, then how fast are the people moving when they're 3 meters from the right triangle? So at some point they're going to be 3 meters out. I should have drawn this as 2 equal legs. The area of this triangle is 1/2 x squared. That's 1/2 the base times the height. So x is changing. X is a function of time. So dA dt is equal to 2 times 1/2 times x dx dt. We are told that dA dt is equal to 2 meters per second. That's equal to 1 times x, and we say x is equal to 3. So dx dt, which is what we want to solve for, is equal to 2/3, equal to 0.67 meters per second. Now folks, number 38 is not a real hard problem, but it's going to take a good bit of studying the detail of what we're looking for. It says a volume of a sphere is increasing at the rate of 9 cubic centimeters per second. Find the rate of change of its surface area when its volume is 32 pi over 3 cubic centimeters. Well, we got several things we got to do here. The volume is equal to 4/3 pi r cubed, and the area is equal to 4 pi r squared. And we want to find the rate of change of its surface area. So dA dt is equal to 8 pi r dr dt. Well, dA dt is what we want. We need to know what dr dt is and what r is when its volume is 32 pi over 3. Well, if the volume is 32 pi over 3, we've got 4/3 pi r cubed is equal to 32 pi over 3. So we can solve for what the radius must be at that moment. It's nice to cancel out a few things. We get r cubed is equal to 32. I'm sorry, r2 is equal to 8, which is 32 over 4. So r is equal to 2 at the point we're trying to calculate dA dt. So now we have that is 2. So how are we going to get dr dt? Well, to get dr dt, we got to look at the rate at which the volume is increasing. Going back to our volume equation, we get volume is equal to 4/3 pi r cubed. So dV dt is equal to 4 pi r squared dr dt. dV dt is 9. R is equal to 2. So we get 9 is equal to 16 pi dr dt. So dr dt is equal to 9 over 16 pi. That's solving this equation for dr dt. So now we know what dr dt is. We can get dA dt is equal to 8 times pi times the 2 times dr dt, which is 9 over 16 pi. Notice I can cancel out pi's, cancel out this, and I get that it's equal to 9. It all comes out even. So the answer is 9 centimeters squared per second. Okay, number 39 is to find the differential dy. Key thing to remember here is if you have dy dx, where y equal a function of x, dy dx then is just simply f prime of x. So dy is equal to f prime of x dx. So if y is equal to 9 x to the 1/2 plus 2x to the minus 1, that's rewriting the term for y. We have dy dx is equal to 9/2 x to the minus 1/2 minus 2 x to the minus 2 equals 9 over 2 square roots of x minus 2 over x squared. So dy is equal to 9 over 2 square roots of x minus 2 over x squared dx. And that is answer D. We have a sphere with a volume of 4/3 pi r cubed, r is a radius. The question is approximately how much does the volume of a sphere increase when the radius is increased from 3 to 3.1 centimeters. Here dr is approximately equal to 0.1. With the volume is equal to 4/3 pi r cubed, we can write that dv dr is equal to 4 pi r squared. So dv is equal to 4 pi r squared dr. dr is 0.1, r is 3, so we get that dv, which is what we're looking for, would be 4 pi times r squared, which is 9, times 0.1, and this equals 11.3, which is answer B.